Good morning, class. How's everybody doing? I see there's been 0 activity in the chat. How many people we got? We got 2 people watching? Are these people even people? Let's see. Oh, 3 people watching. Okay. I'm gonna see if I can find the thing on YouTube. That sometimes has a somewhat higher rate of accuracy in reporting how many people are actually on the stream. That pinned chat. Oh, there we go. Okay, we do have people. Good, 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 good. 3 people. All right. Can confirm not human. Ah. I see Amazon Web Services is watching this morning. Yeah. Okay, so I guess it would be polite to allow people a few minutes to get here. So, in the meantime, since the 2/3 of you have arrived on time, hi! You guys get first dibs at determining what topics you'd like covered during the review session. This is my will and decree. So, so what do you like? What do you like? What do you want? Topics. Give me topics. How long is the test is not a topic? The test is 2.5 hours. So, all right. I will answer these questions, but I'd like to give it another 2 or 3 minutes for people to arrive so I don't have to repeat myself. If that's okay. That's why I asked for review topics, because I didn't want to get into the discussion of the nature of the exam prematurely. How's the latency at the moment, actually? Okay, I'd like to do a latency test. When I clap my hands, if you could just, like, type clap or use a clap emoticon in the chat so that I know how long the latency is. Okay? Okay. 3, 2, 1, clap. 9 seconds. Not bad. Awesome. And it seems like pretty much everybody... Yeah, that's quite good. That's quite good. Awesome. Thank you for that. So, benchmarking. Benchmarking for sure. We will talk about benchmarking. Anybody else got a topic that's just eating a hole in their pocket? Regular expressions. Regex. We'll talk about that. Anything else? String formatting. Will the exam cover both Linux and C programming? Yes. Yes, it will. Okay, I think we've waited long enough for people to show up. So, so the exam then. Yeah. Couple of questions about how long the exam is. The exam has been scheduled for a 2.5 hour writing block, so it's a standard exam length according to the university standards for such things. Will it be similar to the sample exam? So, for those of you who may not be aware, there has been a sample exam. It was the exam for last year, which has been posted to Avenue to Learn. It's right here, practice exam. So it's in structure, and it's worth going through this. So one fundamental difference between last year's exam and this year's exam will not be in the 24-hour writing period format that I have been using while the pandemic had been going on. And, distributed exams were a thing that the university was attempting and failing to really properly do utterly. But that's because they're impossible. This will be a 2.5 hour in-person supervised exam. You are required to physically attend. The exam will be held in LRW B1007. So that's the first big difference. This exam here has been designed for it's not been designed to take you 24 hours, but it is longer than the exam I will be giving you. So it is an excellent view of the type of questions that you will receive, but it is not a good view of the length or duration that I would be expecting of you, basically. So hopefully that's all clear. Ooh, somebody's... is the stream being recorded? Yes, the stream is being recorded. Ways to compile. We can review that. So, so this is how the exam worked last year, right? Basically, I wrote a small program and I left a bunch of the functions out, and it was the object of the exam to fill those portions of code in with your own C code. There was a section both on C programming, which came up front, and there was a section on some of the Linuxy stuff, although I believe in terms of points it was weighted slightly more towards the C programming stuff at this point. You know, the exact breakdown will vary. But yeah, so these questions, some of these questions may show up in almost exactly the same form they are here, however, applied to a different basic program. So this is excellent preparation for the exam, is what I'm trying to say. Are you allowed to use the slides in the exam? No. It is not an open... Our exam will not be an open book exam. Your permitted aid is one double-sided cheat sheet, crib sheet. You are allowed to bring with you one standard 8.5 by 11 piece of paper, upon which you may write anything you wish. But you are not permitted to access the internet, except insofar as you will require the Pascal server to perform the actual exam, because that is, in fact, internet access. But you're not allowed to open web pages during the exam, basically. Anything that you think you will need to know, you'll need to write on your crib sheet. Can the crib sheet be printed? Absolutely, the crib sheet can be printed. However, magnifying glasses are not permitted. That's a joke, actually. You could totally bring a magnifying glass if you wanted to. Yes. Can I repeat that? What is the allocation? So the allocation is one 8.5 by 11 standard sheet of A4 paper. You are permitted to write stuff on both sides of this piece of paper, and that is the only aid that you are permitted during the exam. I highly, highly recommend putting all of the commands for all of the things that we covered in lecture, and particularly in lab. I recommend you putting all of the sequences of commands on your sheet. That is definitely something that should be there, I would say, in my opinion. But hey, it's your crib sheet. You can put anything you want on it. If you want to cover your entire crib sheet in unicorns and rainbows, then you are absolutely permitted to do so if it'll cheer you up as you're failing the exam because you didn't write anything on your cheat sheet. Jokes, jokes, jokes. All joking aside, that's definitely a thing that you want to do, is put all of the Linux commands that we've done. I shouldn't have to tell you how to do a cheat sheet at this point. You should know how to do a cheat sheet. So, the basic overall procedure, you will be provided with a tarball somewhat similar to this, in the same way that we've been providing you tarballs and zip files so far. So perhaps one of the things that you should put on your cheat sheet is how to untar tar archive. You will receive one of these, inside of this is contained a whole bunch of files, right? C source code files and testing files. And, well, the object of the exam is to perform the tasks as given on the exam sheet. Does that all make sense? Are there any questions about that? The exam this year is going to follow more or less exactly the same format. You'll just have, you'll be doing it in a room with other people who are doing it, while, myself and the teaching assistants watch you complete the exam activities. Will the Linux questions be similar to lab questions? Similar to some, not so similar to others. Insofar as a lab question was asking you to perform a task, the exam last year and the exam this year will focus more heavily on your ability to perform tasks rather than your there won't be a lot of requiring you to speculate about things or provide opinion. It'll be more task oriented. So the actual procedure questions of the exam will be provided as a paper, so we don't need to access Avenue. Well, you'll need to access Avenue to get the exam archive anyway. But the exam papers themselves, they'll be available on Avenue, and I'll have printed out copies as well. Can you talk about Git merging? Merge branch. Yeah, I can talk about that. In my opinion is that the internet shouldn't be banned because programming is also testing the ability to find methods to solve problems, not memorizing. Well, it's a good thing that your opinion doesn't count then. My opinion counts. I'm the prof. Your opinion doesn't count. You're the student. Yeah. No. See, the problem is that if we give people access to the internet, all they do is cheat. And, what we require is that you actually have these skills yourself, not, relying on other people's skills, because ultimately we're granting the degree to you, not to the internet. So, no. You're not permitted to have access to the internet, and I don't care how bad that makes you feel. Sorry. But no. Can you use VS Code? I definitely recommend against VS Code. 100% recommend against VS Code. For one thing, what compiler are you using? Because your work is expected to compile under GCC, right? So if you're using a programming IDE where it is not immediately obvious what your compiler even is, then you're probably doing it wrong. So there you go. Yeah, be aware that a lot of operating systems that aren't Linux, when they say GCC, they don't necessarily mean the GNU compiler collection. This is on Macintosh computers. GCC, like the GCC command by default, famously redirects to a different compiler called Clang. Clang is more restrictive about a lot of errors. Like the error sets are not quite overlapping, so a program that compiles under Clang may not compile under GCC, and vice versa. So there you go. What about GitHub? You are permitted to use GitHub only insofar as it is necessary for you to submit your exam work. This should, once again, you will need to create a folder inside of your Git, inside of an existing Git repo, in order to, in order to put your exam stuff in. There will be instructions on how to do that on the exam. And because it's an existing repo, and because, in theory, it should be cloned to anywhere that you've been working on it locally, there should be no requirement for you to actually visit GitHub's website during the exam. If you do, then you'll certainly raise some eyebrows among the people watching. You should know how to do this from the command line, folks. You should know, by this point in the course, you should definitely know how to do this from the command line. Are you restricted to a certain text editor? No, not particularly. Any of the standard ones would be fine. I think Nano is a good one. If you want to use Emacs, go ahead. If you want to use, depending on, your loadout, yeah, just a plain text editor. If you're a person running Windows, then and you're modifying things on your local Windows file system, which I don't recommend, but if that's the way you're choosing to do it, I definitely recommend getting something like Notepad++ rather than VS Code, because Notepad++ does not make any it does not make any pretensions about hooking you up to a compiler, so you don't have to worry about it hooking you up to the wrong compiler. Yeah. Sorry if you already mentioned it, but are we allowed to look at our previous assignments on GitHub? No. No. Basically, anything other than, basic text editor and terminal access is going to require enhanced scrutiny on the part of the people who are watching you perform the exam, including myself. So, if we see you accessing web pages in general, yeah. So, yeah. Yeah. Just your cheat sheet. Just your cheat sheet. Okay? So, can we go over doubly linked lists? Well, I don't think we should, actually, because we're going to be covering them in class on Wednesday. So unless... basically, I can't hold class, right, on a holiday. That's not a thing that's on, right? This is just a review session for topics already covered, right? So I realize the timeline becomes a little tight, but we will cover all of that, all of the remainder of the structs material in sufficient time for you to be able to do your assignments. Could we go over double pointers and passing pointers as arguments and functions at some point? Yes. Double pointers / pass by reference. Sure. Will the exam cover everything, including the last topic? So exam coverage, sure. Yeah, basically, don't rule anything out, with the possible exception of, like, the very last lecture set of lecture slides, which we may or may not get to. This one. So, Topic 13, I'm not sure if we're going to have time to cover topic 13. Fortunately, it's not hugely important. It's not required for the assignment or anything, for example. So topic 13, I'm going to say I'll strike that from the list. You do not require topic 13. Yeah, I'm not gonna strike anything else off the list. Any other topics people would like covered? Right, the C compilation stuff. So Doxygen. Yeah, we can do that too, yeah. Doxygen. Right. So, and we've got some people interested in regex. Yep. Oh, the baby monitor is on. All right, give me 2 secs, guys. 2 seconds, pardon me. Jeez. All right. Oh, yeah. Yes, to confirm, assignment 2 is due Thursday evening, not Wednesday morning. I'm giving you until midnight on Thursday to complete assignment 2. Oh, and while we're on the topic of assignments, so we've been furiously working on getting assignment 1 graded. Sorry about the delay on that. There was a little bit of problem with the code, and that needed a certain degree of redevelopment. So these are the class statistics. Generally, I think this is pretty good. I think people are doing, about where I expect people to be doing, more or less. The people who submitted anything, anyway. It's a little bit on the low side, to be honest, but, like, the average could be a bit higher, but, most people who attempted the assignment passed, and I'm pleased about that. Yeah, or nearly passed anyway. So yeah, so that's how assignment 1 went. I believe there are still a few people who might have some work left to be graded. The TAs have been complaining all weekend about you guys not being able to follow simple instructions in how you determine where your files and folders are. If you don't have a grade yet, that's probably the problem. One of my, Ryan Howard has been going through all of the submissions that failed to auto-grade because people put their files and folders in the wrong places, and has been manually adjusting things so that, so that those grades come, He's been fixing things and applying penalties as he does, because that's only fair. But yeah, so a lot of people fail. Like, it was kind of amazing because, like, we gave you a compressed archive that contained the exact, folder and file naming structures that were required by the auto-grader. And, like, insofar as that was modified, things, failed to auto-grade, so we have to go in and do a bunch of manual modifications to things. So, even when it said on the assignment specifically, do not modify this structure. But, I guess that it is what it is. From our perspective, that looks like a failure to follow simple instructions, and generally speaking, failure to follow simple instructions is something that marks get taken off for pretty much no matter what course you're in. So, yep. All right, so let's talk about these topics now. So let's talk about compiler options first, because I think that's easiest and will frame the rest of everything. So, let's begin with the actual review. Yeah, yeah. It doesn't matter if you're, like asking a TA, did I follow these instructions correctly? It's like, yeah. People can make all kinds of claims about, oh, the TA approved this, and it's like, well, it doesn't really matter if they did, if they were wrong when they did, Ultimately, it's the autograder that determines whether or not something is processable by the autograder. So, let's review. There we go. Let's just spin up a quick C program, or copy one over probably is more useful. Hello.c will do. So, just to remind ourselves, let's take a look inside hello.c and see what we got. So, very simple program that takes two numbers, sums them together, and prints them out again. One of our earlier examples in this course. Select a course. Get out of here. Stupid thing. All right. So, regular compilation. Right? GCC, the -O flag. When you use the -O flag, the next thing that you type is the name that you want the executable to have. Right? So let's say hello, and the file that we are compiling is hello.c. Creates the executable. So far, so good. Good. Including the WALL flag enables all warnings. It stands for warnings all. So this gives you an extended set of warnings that you might not necessarily have without this flag. In this particular case, it's a very simple program, so no additional warnings are generated. But the extended set of warnings include some things like whether variables go unused. So, for example, if I say int x, and I just put that in there, under WALL I get a warning, unused variable x, and I believe if I disable it, yeah, it doesn't warn me about that. So that's what the WALL flag does. All right? So let's remove this executable, and let's talk about the C flag. So you'll notice when I use the C flag, I do not produce an executable file. I produce a .o file. I produce a object file, right? In what situation do you need to use wall? Well, you never need to use it, right? It's providing you additional information about your program. If you want your program to be like extra good, then you will deal with all of the warnings that come up through wall. However, these warnings are not necessarily related to the proper functioning of your program. They're sometimes stylistic things. Sometimes you're wasting some memory over here, that sort of thing. Sorry, I have a floating fuzz on my camera there. So, so using the wall flag is not necessarily, it's not required, but, certainly if you're showing the code to anybody who you're trying to impress, your code shouldn't have any warnings, even under extended warnings, right? But, for example, for the purposes of a test, you don't need your code to you don't need your code to not return any warnings under wall, because we're not grading for that. We're grading for bare functionality, if that answers your question. So with object code, so the C flag, it generates an object code file instead of an executable file. This object code file can be used by other compilation processes in order to break the compilation of a large program up into several small pieces, so that you can do them individually using Makefiles. Right? So let's just quickly go back and take a look at Makefiles, since although nobody asked about Makefiles, it does, the C compilation stuff gets into Makefiles pretty heavily. So, because that's where you would see it, right? So, oh, forgot that that's, there we go. So as you can see with this Makefile that we did in class, we've got our top level program, right? That's basically requiring top.c and then a bunch of object files from sums, products, and sea shanties, right? We have rules for generating all of these object files, each of which includes the C flag, which tells us the object, tells us to generate object code. The invocation that produces the top executable itself includes all of the object code files which have been generated by these rules, right? In this way, for example, if I open up a terminal in this directory, if I say, for example, let's just so top is up to date. Let's touch one of the source files, like touch sums.c. That updates the timestamp to the current time. Sums is recompiled. Top is recompiled, but products and sea shanties are not recompiled because they haven't been updated. That's what a Makefile does, right? So there you go. Any further questions about the manner in which C programs are compiled? Remember that when we generate to object code, we are not performing full executable generation. We are pausing generation before the linking phase. So before function uses get linked to their definitions. We then continue the linking phase when we're generating the full executable. Will the Makefile fulfill the prerequisite first? Yes, if you do things correctly. So when you put file names after the colon here, you are saying that each one of these files is required for the generation of this file here. So it's like target, prerequisites. How Makefiles work is it goes through each file which is listed as a prerequisite. It compares the timestamp of this guy with the target, right? If the timestamp here is less than the timestamp here, then this has not changed since this executable was created. So there's no need, right? Anytime a target which has another rule is invoked, you jump to that rule, check to make sure that that doesn't need to be run. And if it does need to be run, you run it. So yes, all prerequisites are processed prior to the top level file being processed. What about the one in... What about in one of the prerequisites, prerequisite contains another rule? I'm not quite sure what your question is asking, but if you're asking, can these also have prerequisites that need to be generated? Yes, absolutely. This can be a branching structure of compilations that is as deep as the file hierarchy, the import or include hierarchy of your C program is. Basically, like roughly speaking, you'll probably have one of these for every C source file in your entire thing, in your entire program. Make sense? What's the benefit of using the CC variable? Because if we wanted to, we could, like, let's say we were developing for, a number of different systems, and we wanted to see how the program behaves under Clang. All we would have to do is replace GCC for Clang, and then we would be then the same, like, all of this still applies to the Clang compiler, and we can change what compiler we use quickly and easily. If we wanted to see how this behaves under the GNU C++ compiler, we just replace it with G++. In theory, everything should be fine because C programs are a subset of C++ programs. Okay, so I can just put products.o to be the prerequisite of sums.o. You mean like, yeah, you could, in theory, make this target a prerequisite of that target. However, this invocation does not actually require products.o, so in this case that wouldn't make any sense. But if it did make sense, then absolutely that you would be able to do that. Make sense? Any further questions? What does the O3 flag do? That's level 3 optimization. So I have a slide on that somewhere. I think it's in the in the lecture on Makefiles. So GCC has some optimization options, which basically take your code and rearrange it to be more efficient. Sometimes in ways that require, access to assembly code in ways that you couldn't even perform if you wanted to. But level 3 optimization is full level optimization. That's as much optimization as GCC can produce. It greatly increases the compile time, but you do produce a as efficient and executable as it is possible to get to using only automatic optimizations. The GCC optimizations are really, really good. They've had decades and decades of research that have gone into them. So it's a good idea to optimize when you're producing something for final consumption, shall we say. Most of the time you wouldn't use optimization because, if you're doing like, develop test cycles, that takes too long. And it can also like mess up profiling. So, but yeah, that's what O3 does. Any other questions? So, let's do benchmarking next. Profiling and benchmarking. So, basically, with respect to profiling, there are two big things that you want to know how to be able to do. In the first place, you'll want to know how to use gprof. And in the second place, you'll need to know how to use gcov. So, there's the thing on optimization. So this is the process, right? You compile your program. In this case, we've got a program called fib.c. And I think I'm just going to remove a bunch of this stuff so that we have something clean to work with. All right, so now we just have our source file, right? So basically, these commands should be written on your cheat sheet somewhere, all right? These are important slides. So first, in order to use gprof, you have to compile with the PG flag enabled. fib.c, fib. Fib. All right. Then you execute. So fib of let's say 39, sure. There we go. Then we run gprof. So gprof on the executable. So fib, store the results in a file, let's say results.txt. There we go. And if we take a look at the contents of that file, bing, bang, boom. At the top here, you'll get the flat profile. Down here, you'll get the graph view, and that will include such information as the number of times each function called every other function. So you can see fib calls fib like, 200 million times, but main only calls fib once. That's the type of information that's revealed in the graph view. All right, does that make sense? Any questions about gprof? What's the time? 10:21. That's so I believe this is the percentage of the time spent in this function. But and all sub-functions, it looks like. So, yeah. A certain amount of time was taken up generating the gprof results itself, right? But yeah, so 98.1% of this time was spent in the fib function. After that, like main, practically no time at all, and then 1.9% was spent by frame dummy, which I believe is the function that generates these results. What information is important for us? Well, I already said it. You need to know how to generate these results, and you need to know how to interpret them. I don't think I can explain it any more succinctly than I just did. So let's talk about gcov, right? So gcov is different. It doesn't, so gprof breaks things down at the level of functions. It tells you how many times each function was called. gcov breaks things down at the level of individual lines of source code, tells you how many times each line of source code in your program was run, right? So the way that we perform gcov is as follows. We have to enable the fprofile flag -args ftest coverage. I might be getting these slightly bad, but we'll see how it goes. Fib.c. There we go. So that produced a couple of files, right? We then gcov fib.c, right? Created fib.c.gcov, right? If we then take a look at fib.c.gcov, you will see that we have a I think I've run it too many. Oh, I didn't run it with You have to actually... Let's see here. Yeah, you're supposed to execute the file. I missed that. So, you should put a note in on your cheat sheet that between these two, you actually have to execute the file. So, let's say it's a.out this time. A.out. Give that 35. There we go. Now we gcov it. And now we view the gcov. Reload. And there you can see it puts our numbers in. So you can see, if, for example, I was going to ask you on a test some kind of silly question like, how many times is line 8 executed, you know, under this test, when you run this test file on a program, you would be able to generate gcov results and give me this number. That's the type of thing I consider testable. Okay? Any questions about that? Okay. I'm going to call that benchmarking. So on the exam, you would not ask what tools to use. You would give us a task, and it is up to us to determine what tools should be used to solve it. Yes, I would say that part of the knowledge that you are required to have picked up over the course of this course is what all these tools do and what they're good for and what their use or purpose is. So yeah, if I ask you, if you run this file, how many times is line 27 in x.c run, you should think to yourself, oh, that's a gcov question. Yeah. That's that. And if you need some hints or reminders about that, then you should put that on your cheat sheet. But yeah, I do expect you to know what the programs are for. I'm not gonna tell you necessarily what program to use to accomplish the task. That is definitely something that you should have picked up from this class. All right, I'm gonna have like 2-minute break, and then we'll get back to it, okay? So, good. All right. Moving right along then. So I think I'll do git merging very quickly. Now, let me take a look what I got here. I thought I saw I had lab 3 already cloned locally here, so let's take a look. Oh, let me just close the door. So, let's see here. Git log. Git log. There we go. Git log. One line. Graph. There we go. Oh, this doesn't look correct at all. All right, well, I'll just make a new folder and throw it in there. Oh yeah, it's in the 1xc3 organization now. Okay. Clone. There we go. So now, oh, maybe it was correct. I think I was wrong. I think I'm just missing like all or something. Yeah, that's okay. We'll just go with it. One line all graph. One line, not online. Yeah, there we go. There it is. There's everything. So let's just merge something here, and let's do that. So generally when you're picking stuff to merge back together, it's a good idea to like attack these branches, you know, sort of, you know, do the greens or do the blues sort of thing. So let's pick the green one. So we will start by making a note of the two branches that we're trying to merge. So it just helps to write down the names. We'll do Spenny's branch. And that would be valid move check. Valid move checks. So git checkout Spenny's branch. Branch is, yep, now set. There we go. So we can take a look at chess.c inside Spenny's branch. So this is what it looks like. Bit of a mess, but you know, there you go. So we've got definitions for king and bishop and knight and pawn, but we're missing a definition for queen. If we check out, which was it? Valid move checks. Git check out valid move checks. There we go. This, if we reload the file, will now be what is contained in valid move checks. So you can see we have rook in there, which I think we were missing in the other one. I might be wrong. So git merge Spenny's branch. How was that even spelled? That was the point of writing it down, Nick. Spenny's branch. There we go. Merge conflict. Haha. All right. So we now reload this, right? We take a look, and uh-oh. There's one. And there's the other version, right? So this is the version in Spenny's branch. This is the version in the head branch, right? So what you do is you take the stuff that you need from one and you put it in the other. So of the two of them, I would say that probably this one's more complete, right? So, well, let's take a look, see if this if structure is more or less the same. Yeah, the if structure is more or less the same. Check to make sure you've got all of them present and accounted for. Yep. Good. So then you can start splicing it together. So this stuff needs to go there. Checking this, checking So obviously the board returning false, we don't need that anymore because that's fine. King logic, is there any differences? There is no differences, so that's fine. Queen logic is absent in both, so we just leave it absent. Bishop logic is absent here, so we add it. So I'm kind of like merging it into the top, which is fine, you know. As long as you remove everything that needs to be removed, then everything works out. There we go. Rook logic is absent here. Bishop logic is there. Knight logic is there. In Spenny's branch, we were absent both. We were absent the knight logic, so that's good. We've got that now. Rook is absent in there, so we pull it in. Boom. There you go. Is there any difference in the pawn logic? Aside from this if statement, which is or print statement, which is probably useless. No, so we can just delete that, and get rid of this here. Bing, bang, boom. And there should be a middle divider somewhere. But at any rate, you then save the file, git, commit, right? Unmerged files. Unresolved conflicts. Oh, is there more than one conflict in here? Oh, I think I forgot to git add. That'll be fine. Git commit. There we go. Merged branch. Yes. Git. I'm not going to push because that would be disaster. But if we take a look at git one line graph all, git log with all those options. Hello, bud. Say hello to the stream, Mr. Felix. Yeah? Ooh. Yep. Hello. Hello. Yeah, that's you right there. See? Yeah. Anyway. Hope. Wow. There we go. Thank you. So, if you take a look now, we have a difference. This Spenny's branch now merges into valid move checks, which means that that branch is now closed. And if we, for example, check out main, and take a look at the graph as well. Yeah, it's showing the, like main is down here, but this is the most recent activity, so it's putting it at the top, right? So yeah, so that's, it's like wash, rinse, repeat that about 10 times, and that's lab 3 finished. So there you go. Yeah. Oh, are we trying to merge valid move with Spenny? Yes, that's what we were doing, yeah. Hi! Yeah, he's gone now, but yes. So there you go. I'm going to call that get merged. We have merged the get merge material into our review session successfully. Good. So, let's do some double pointers then. Okay, we switch to the branch and merge it into main. Well, selecting where to merge is kind of a bit of an art form, right? It's kind of like I need a drawing program. So let's imagine that you have, you have a repository with a commit history, right? Let's say that there's a branch over here. There are a couple more over here, right? It branches off again. This branches off here, right? Let's say it's a fairly complicated one, right? With lots of branches, which is the situation that you were in, right? So let's imagine we've got all these 5 branches going on. 6 branches, actually. In order to minimize merge conflicts, it makes a lot of logical sense to close branches that are closest together in the merge branching structure. You wouldn't, for example, merge these guys together, right? That would not make sense. You would want to merge things together close, right? Because that's going to minimize the amount of difference between them. So you'd merge these two, right? You would merge these two. You would merge these two. And then, at this point, you'd probably merge this one together with this one first, because it was picked off more recently. And then you'd pull this guy down and merge everything back into one. Right? Does that make sense? It's like if you pick 2 branches that are far, far apart from each other, you're going to have way more merge conflicts. So if you pick ones that are adjacent to each other in the graph hierarchy, then it minimizes the amount of merge conflicts, and that's generally a good thing, because you're relying much more on Git's automatic merging mechanisms rather than your intelligence, right? Does that make sense? Good. So, I'd like to talk about double pointers then. So, the place that you really get into double pointers is when you're doing stuff with arrays. So let's make a C file, dp.c, right? Include stdio.h. Let's say we had something like void main int array is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So let's say you wanted a linear search function, but you did not want to return, say, the coordinate index of the thing that you wanted to find. Let's say that you wanted to return a pointer to this thing. We could also do it as intervals, but this is sufficiently simple for this example, I think. We want to keep the example understandable. So linsearch, we will take a int array as a pointer, constant int array pointer. Let's make that a double pointer because we're working with double pointers. And let's do an int double pointer position. Yeah? So, oh, and of course you'll also need the thing you're searching for, int element. There we go. So, linear search is very easy. Let's create a new pointer. So int pointer current is equal to well, let's set that equal to array, which has been dereferenced once. Right? So this is let's draw I would do this on the board, but you know, this is sort of the situation we're in. So, actually, you know what? This might be even better on Python Tutor. There we go. Let's just do this here instead. All right. So let's just put that in there and return. Let's just do nothing. See how this works. So we'll have an int pointer. I call it PTR for classic's sake. Equals null. And let's say linsearch over the address. We'll give it the array, but the address of the existing array, we're searching for 7, and we are also giving it that pointer by its address. Right? So let's get out of here, you. Visualize execution. I have a syntax error. So, we initialize array, we initialize pointer, we enter linear search, right? So, array is a pointer to the array that's been declared here, right? Array itself is also a pointer. Current is a bad pointer for some reason. So, good. So let's modify this then. Let's add some code. So we want to dereference array, right? That's essentially the same as saying that this is pointing to the first element of the array, because that's what pointers point to, right? So while, oh, I suppose we'll need the size of the array too, won't we? Okay. Well, we could do that, or we could use more pointers. Int end of array. Could do that as well. Oop, get out of here, you. So int end is equal to array, the address of the array at 9. The address of the 10th element of the array. I hit Control S to save so much. So, while the value of current, which is the value of the pointer itself, is not equal to the dereferenced version of end of array. That is to say, while current is not pointing to the last element of the array, we say current if current dereferenced is equal to the element that we're looking for, then we do some stuff and we return. Doing some stuff in this case is setting the value of position dereferenced once to the current value of current, right? Otherwise, current plus plus. There we go. And that should do what we want. Otherwise, let's return element as -1 or something. Or not element. Let's return position as null. Oh my god. All right. Oh. And of course, I need to actually provide that. There we go. Wait a second, there was options there. Draw pointers as arrows. Use text labels for pointers. No, I think pointers as arrows is better. Array itself represents the memory position of the beginning of this array. Yes, exactly. Yep. So, we have array, we have end pointer. Notice that end pointer is pointing to the end of the array. Whoa, you can grab those? There we go. I can grab that and, like, pull it around. How did I do that? Very strange. Anyway. And pointer itself is null. We enter linear search. So notice, right, particularly in the case of end of array, right, that we're pointing to this pointer, which is pointing to the end of the array, right? This is the double pointer. This is the double part of the double pointer. Array is doing the same thing, but array points to the first address, so it's not like visible here, but here it makes it explicit. This is what makes it a double pointer, right? So address of the array means the pointer of the pointer. Yeah, so we take this address and we return it as a value, so we place it here. That means that we now have a pointer to the beginning of the array. In the same way that end of array points to end in main, which points to the last element of array. Good. So current is apparently thinks it's having a problem. Invalid read size of 4. Might have a slight error here. So not sure why it should be telling me that that's wrong. It's very strange. I'm going to try it on my machine. See if we get the same thing. And you were asking why warnings are helpful. All right, well, we'll play along. For the time being, anyway. Now it's expecting the other way around. maybe try the address of the first element. But that would be a single. Yeah, let's see if that works. We'd have to take that down. Let's see. So address of array means pointer of the pointer. Well, in theory, but seemed to not like that, so we'll try it slightly differently. So, current. There we go. Yeah, that works. So, while current is not equal to dereferenced end of array, which is this pointer here, right? We go through, test to see if element is the same. If not, increment the pointer. Increment pointer, increment pointer. In this case, we do find it. Position is then set to current, right? So before that, if you'll notice, this guy here, which is pointed to by position, was null. After this line of code is executed, it is given the same memory location as is currently current. So you get this arrow forming here. And then that's the end of it. Does that make sense? Hopefully that was useful. Cool. Uh-oh. Array at 0 is not a pointer, no. But the address of array at 0 is a pointer to the first element of the array. Which, in theory, I should be able to just eliminate both of these things and have everything work the same way. It's kind of redundant to put it that way. Yeah, everything still works the same. Array is the address of the first element. Yeah. So, all right, let's I think the problem here is that I'm using the array here, and it's like not liking the type compatibility. So let's modify this so that it uses pointers instead. All right. So we'll also have to include standard lib. .h. There we go. Let's malloc this 10 times the size of int free array, right? For int I equals 0, I is less than 10 I plus plus. Array if you dereference, yeah, let's make a secondary pointer. Temp is equal to array, dereference temp, assign I, there we go. Then when we give it here, we should be able to just have the double pointer like we were having before, and everything will work out. Well, I mean, in C, you're kind of always forced to manage memory, right? So, we've malloced the int array, right? Temp is a pointer to the first element. We loop through. I forgot to increment temp. Temp plus plus. There we go. There, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Populated the array. And there we go. We set end, we set pointer null, and then linear search. Oh, did we hit an error again? Invalid read size of 8. Doesn't even, what? Show me my warnings. Argument is of type int. Did I forget to, Yes, I did. I had that running the wrong way. Ha! That'll do it. So now we should be able to give the address of that pointer. Everything being fine. Run through, run through, run through. There we go. So there we go. Good. So current does get set to the first element. We are looping through in the correct manner. We hit 7. This guy gets set. There we go. Boom, boom, boom. Everything's finished. The pointer now points to the found element. Ta-da! There you go. So, and that gave you a little bit of dynamic allocation as well. So, you know, the full size screen show. What? Oh, you want to see all the, you want to see the code all at once? Yeah. There's the code all at once. There you go. Hopefully that's good enough. I'll pose for your screenshot. There you go. Cool. So, let's talk Doxygen. Let me just poke around in here. Hmm. So, I'm assuming that everybody is like, nobody needs to be told the manner in which the doxygen, like the doxy file, gets generated and the manner in which you actually generate the documentation, right? Um, you know, essentially, you know, so long as you're inserting comments in this manner with the doxy tag, then, and providing the description that's being required, then that's how you document, right? This is how you include these various parameter tags, right? So yeah. So, documentation. That's how you do it. I'm not going to test you on, like, how to hook it up to GitHub pages or anything like that. In fact, you can pretty much assume that, like, the labs... I know I said nothing's off the table, but, like, the Lab 7 stuff? No. Lab 7 is good. I'm thinking of Lab 8. The stuff with, like, GitHub Actions and stuff like that. I won't test you on GitHub Actions on the exam. So, yeah. Good. So, I guess we could talk about string formatting. It's not, like the formatting tags. It's like, do you have anything more specific? I'm not going to do your assignment question for you. Like, what specifically would you like to know about string formatting? Ah, you have a question. Go for it. When using string token on a constant characters array, it gives a warning because string token modifies the string. How do we deal with this? I would need to see the code. Could you email me the code quickly? I'll take a look. I won't show it on screen. I'll have it on my second monitor. Sent. Received. Okay. There, I just wanted to make sure it wouldn't flash on screen. So, where are you using string token? You threw me off for a second because you've not, like, indented everything. I thought you were, like, using string token in, like, the global namespace. My goodness. So let me just take a look. I don't feel like you're using enough arguments. You probably are. I just need to check my brain. Yeah, GCC documentation will be better. Or anything. See string toke. Okay, so string token is one of these interesting ones where it expects a pointer to the thing, not the thing itself, right? So... But I will say that you don't necessarily need to... I'm looking at your code right now, and yeah, you're kind of like using string token to try to avoid needing to use any kind of more complex like parsing string formatting, right? Like you're taking the string and splitting it up with string token instead of like using the formatting tags to do that work for you. So that's a possible reason that, you know, you might have more luck if you didn't use string token. But yeah. Try passing it, like, try creating a pointer to the first element of the string, and then giving that to string token to chew on, rather than, like, the only reference to the string. If that makes sense? Let's see. So... constant means, yes, constant means that this is read-only, right? But this is the delimiter, right? So this is a pointer to the string containing the things that it splits on, right? So that is all very correct. What string token is supposed to do is you give it a pointer to a string, and then on subsequent calls of string token, it will dump out pointers to the subsequent tokens found in the string. So it's kind of like it works a bit like Python's split, but rather than giving you an array of or not an array, a list of strings or a tuple of strings or whatever, it gives you in time a sequence of pointers to the positions in the same string where the things are different. But yeah, if that makes sense. Cool. All right, I'm going to consider that question answered. And I'm going to, we'll just cross off string formatting. Incidentally, I'll give you a couple of pointers about string formatting. You can include multiple formatting tags in an input string. I'll show you a couple of things, right? So just to have something to write in. If you've got something like that, and you're doing your scanf string, we've done it where it's an integer, and you give it the address of my int, right? That's the type that we've seen quite a lot of. It's possible to do my int, you can do the same thing in scanf multiple times, right? That's possible. This character will be read literally, so this is reading two integers that are separated by a single space character. This doesn't have to be a space character. It could be the letter capital Y. It could be the letter capital Q. Any character on the keyboard can be put here, including ones that appear in the assignment. So that is a quick and easy way of reading multiple pieces of information out of a single string without having to break that string up into substrings before you do it, which is what you were attempting to do, which is, the more complicated solution and therefore more error prone. Although I will say that was a better solution than that terrible solution that I discussed in class by a country mile. But still, it could be more efficient. So yeah, does that make sense? Okay, and regex is not on the exam. Neither is sed. Hooray! I will declare that right now. So, are there any further questions? We've been at this for about 2 hours, and I think that is. I think that's sufficient for our review session. So. Good. All right. Any other questions? Is there a way to get solutions for Lab 10? Yeah. I do have a set. So many of the commands that were performed in Lab 10, there are multiple ways of going about them, right? But I do have solutions for all of those questions, obviously. So I don't want to distribute them electronically. I'm not going to post them generally. But let's say if you want to take a look at what the solutions are for Lab 10, how about you follow me back to my office after class on Wednesday, and I'll let you have a peek at the solutions, anybody who's interested. Okay? but I'm not going to distribute them electronically. Sounds good? Oh, that's okay. You know, I'm not your dad, so you don't have to apologize for your sleep schedule to me. Yeah. All right. I'm going to call this stream here. Thank you very much for all of you who attended. I hope that this will be valuable for you come Friday, which I'm reasonably certain that it is. It will be. Please, please, please attempt the practice exam that I posted. That's going to be very good studying. That's going to be very good prep for the exam. I know I've said that like 6 times already, but, you know, in case it needs to be said one more time, I'll say it one more time. Try the practice exam. Okay? See you Wednesday.